Hello, welcome back everyone. And today, our lesson is going to be moving into the idea of energy. And that is the idea of energy is causing change in our various environments, in our own homes and outside our world. Everyone thinks of energy as like lightning and electricity and things like that. But energy is much bigger than that. Alright, so again, definition of energy. Causes change, does work. So, moving past that, we're going to talk about 6 forms of energy today. The first one being thermal, chemical, light, electrical, mechanical, and sound. So I'd like to go through and just take a look at our normal home. So obviously, kids, I'm in my kitchen, nothing exciting, nothing fancy. And I can find every one of these inside my kitchen, no problem. Obviously, the thermal has to do with heat. So anything heating up, we got a microwave right here, right? It's using its energy, microwave energy waves, to heat up the water molecules in the microwave. Obviously, there's nothing in there right now because we just ate already. Next, the biggest one is most likely is you guys have your ovens or stoves. You can turn on. We have gas. We can clearly see the visible flames. I can feel the heat. This is a big, pretty straightforward form of energy. This is what we're using for cooking most of the time. And obviously it is very thermal. Oven, another good example. Don't need to turn on the oven. Definitely don't need to turn on the oven. Nothing in there. The next one is chemical. Now, chemical is a little trickier to think about in terms of where you would find it in your kitchen. There are quite a few places to see it in your kitchen. One of them is being just your basic dish soap. It is having a chemical reaction and is killing most of the organisms or food or just cleaning in general. Usually below the cabinet you find tons of chemicals. Alright, so we've got 409. There's even chemicals on here. I can't pronounce that one. But definitely disinfectant of sorts. And then bleach. Bleach is a chemical reaction once it gets on any surface, killing anything. A more natural, organic version of chemicals is basically food. When you eat food, it breaks down the chemistry. You absorb it, use it as energy. These bananas are riper than this one banana. So this one's actually having a chemical reaction in the form of decaying, which some would argue it's in some sense of form of radiation, in a sense, giving off and breaking down its chemical structure over time. What else? We have light energy, and that's obviously real easy. We have light here, we have light above us, we have light over there, and then of course, if we even turn back on the stove, there's a visible light that can be seen in this form of energy as well. Light is pretty common, but the more, I would say, like the energy that most of us all think about and constantly know about is electrical energy. So electrical energy is constantly running through our home, right? We have the timer here, we have the clocks, the fridge right here is running. It is running? It's running, and the guinea pigs every time we open the fridge. I don't know if you can hear that. That's like clockwork. That is some animal energy right there. Dishwasher, rice cooker, coffee maker. All forms of electrical energy running through them, powering the devices. And which leaves us to our next one, which is mechanical energy, which is basically any sort of moving object that doesn't use all the other energy. So like this hinge on this stove is a mechanical energy. We have the can opener over here. We have probably like the coolest salt shaker in all the land. It even has light energy and a little grindy noise. Do not waste the salt. It's okay. There's plenty of salt in the world. So mechanical is pretty straightforward. Think of your cars, your parents' cars. Think of like the standard like gears in motion kind of thing. That's mechanical. And the last one we talked about was sound, which me talking right now is producing an energy in the form of energy waves. It's hitting the microphone, hopefully well enough. When you clap, you create sound, which is more energy. And you can actually feel it. That's when your hands get warm. You actually have energy building up from the sound. Alright? So, now that we've talked about our 6 sounds, I invite you to take a look in your own house. Try to find all 6 of them somewhere, somehow. It shouldn't be too challenging. And then we like to talk about the 2 types of like how the energy is given off. All right? So I'm transitioning from types of energy into, is it taking in energy or is it giving off energy? More often than not, things tend to give off energy. That's how we know. Versus taking in energy. We as humans, when we eat, we are taking in energy. There are other forms of taking in energy, but the term for taking in energy is called endothermic. And commonly, when you're taking in this energy, it tends to feel cold. Like in our experiment we did on a few previous weeks, the energy taking it in absorbs all the energy, which creates a cold feel on the surface. So your fridge is actually an endothermic reaction taking place inside your fridge via a cooling pump in the freezer. All this you can kind of see. This is endothermic. It is absorbing all the energy, creating a cool environment. Where is the energy going? It's actually going into the pump on the back, and you can feel the back of the fridge. Sometimes on the bottom of the fridge it tends to be warmer. That's where all the energy is being released. Another example is exothermic, which is the idea of giving off heat. If you hold your hand over your arm, you can kind of feel the heat coming off your own body. The oven gives off tons of heat in the form of thermal heat. And then of course, the stove right here, tons of exothermic heat. Exothermic reactions tend to be big, boomy, loud explosions. That's all the energy being released all at once. Right. So, exothermic means means out, meaning explosion, so X as an exit. Indo and in mean taking in. So exothermic out, endothermic in. Which brings me to my last thing. Here's a fun little experiment that you can do at home. Obviously, have your parent or guardian help you out. Make sure you don't wreck anything. But we're gonna create an endothermic experiment, meaning the energy is gonna be taken in and creating a cooler feeling. But there's also gonna be some byproduct, which looks pretty cool too. Some of you may have done this already before. It's very simple. Most of you might even have the ingredients at home, which is why I wanted to do this experiment, because it's easy. We have in glass container number 1, standard baking soda, simple stuff. And in the glass container, over here, we have vinegar. Alright. Most people use this for fun in their science projects or their science fairs, for making volcanoes like erupt and look like that. So you can make it cool different colors. I think we should make it cool with different colors. I have some fun sort of pastel colors. Not very exciting, but hey, it'll be interesting to watch. So, in the Human of the World, we're gonna make a blue volcano eruption kind of thing. So we just put in food coloring. Handy dandy stir stick. Some people call these chopsticks. Alright. And then you just pour it in. And it should be a big fun reaction. It won't actually hurt you, but I can actually tell you, I feel it's really cold on the actual glass. And it just foams up. It makes a fun little cool project. Very endothermic cool. Alright. Hope you guys enjoyed this. Hopefully more to come. And hope everyone's staying healthy and safe inside. And I will hopefully have more videos upcoming. Thank you for watching. Bye!